Hello guys, I'm Smith Thakkar and today I will talk about my research paper YouTube presentation assignment. My topic for today's presentation is MongoDB distributed database. So now let's get started with MongoDB. So here are the contents which we will cover throughout this video. We will start from the scratch introduction and we'll cover the advanced topics like replication, distributed transactions and shredding. I will try my best to explain each topic in depth and try to clear every confusion. So let's start with MongoDB introduction. So MongoDB is NoSQL, scalable, high performance, open source, document oriented next generation database. MongoDB is faster than SQL database. MongoDB has high readability. It means that MongoDB's queries are easy to understand. MongoDB has high performance. It means that MongoDB is more productive than RDBMS, the Relational Database Management System. Is MongoDB has high availability. Actually, MongoDB has a concept uh, like replication which increases its availability, and we will cover replication in later of in the video later. MongoDB has high scalability. Uh, Again, MongoDB has a concept named sharding which increases its scalability, and MongoDB do aggregation of map entities. We will cover scalability, we will cover sharding and replication topics in the later part of this video. Okay, the next is the reason why we need MongoDB. As you may already know, internet is generating huge number of data each and every minute. And someone has rightly said that data is the new oil. If you utilize this data, it can be very helpful to your company or organization. Modern applications are social, networked, and interactive than ever. This requires support for big data, faster development, and flexible deployment. Database is storing more and more data and accessing higher rates. If database is running on a single machine, it will reach a scaling limit. Even if you design a very high configured machine, it will reach to its scaling limit anytime for sure. So till now, you may get the idea of first reason of why we need MongoDB. Yes, it's for it's for scaling. MongoDB has high scalability. MongoDB scales by adding more server. You can add more capacity whenever you want. If your database is not flexible and scalable, it can slow down your deployment. This way, MongoDB increases productivity. Now let's dive into the benefits of MongoDB. Till now, we were familiar with SQL or Relational Database Management System because of course it's more than 40 years now since RDBMS was founded. High-level programming languages like Python, Ruby, Java, R work with only objects. So we need a database which directly stores objects, not data. And yes, MongoDB do that. MongoDB stores document or object. MongoDB is also supports distributed architecture. So the question may arise that what is the actual difference between MongoDB and RDBMS? And the answer is in this slide. So let's first talk about RDBMS. So on the left hand side you can see two tables which are part of RDBMS. The first is position table and it has columns like position ID, name, price, vendor ID. And the second table is vendors table which has columns like vendors ID and name. Now on the right side we have MongoDB. In the MongoDB, data stored as an object and objects are stored in document and group of documents are called collection. Okay, I hope you understand the difference between RDBMS and MongoDB. If not, then let me try again. In this slide, I have explained the difference between SQL or RDBMS and MongoDB structure. So as you can see in SQL, we store data in rows and group of rows forms tables and all the tables forms a RDBMS or a SQL database. While on the left side, as you can see, in the document we save objects and group of documents forms a collection and group of all the collection forms a MongoDB database. Okay, so now we will talk about data models of MongoDB. In this video, I will explain two data models of MongoDB. So let's start with the first one. And the first data model is normalized data model. In normalized data model, relationship between data is in normalized data model, relationship between data is represented by references. So now let's understand it by given example. So in this example, there are three documents. The first is user document, the second is contact document, and the third is access document. Now here, as you can see, every document contains some data fields and value for it. Now if we see, before going into depth, let me explain the format of a document in depth. Whenever you see an opening parenthesis, it means that the document is started, and whenever you see a closing parenthesis, it means that document is ended. Now in this contact document, if you can see the user ID data field, it has the value of a reference. Now this reference object ID 1 is referring to the user document. So this kind of model is called normalized model. The same way in access document, we have user ID field and the value of this field is a reference to the same user document. Now another question may arise that when should you use normalized data model? The first is if you are facing duplication problem by embedding data. If you are using embedding data model and you are facing duplication problem, then you should use normalized data model. The second is to represent more complex many-to-many relationships. Normalized data model is very useful when you want to represent many-to-many relationships. And the third is to model large hierarchical data sets. Now the second data model is embedded data model. In embedded data model, you can embed data in a single document. You don't need to give any reference, unlike normalized data model. Now let's take an example and understand it. Now here as you can see, we have one single document, the single parenthesis starting and closing. Now in one document we have several data fields like ID, it is the ID of the object. Username, we have one value for username. Now in contact we have subdocument as the value. Now this is really interesting. In contact we are giving the values by a subdocument. This kind of mechanism is called embedded data model. We can actually embed some document as value. The advantage of embedded data model is that it allows application to store related pieces of information in the same database record. Embedded data model is also known as denormalized models. Now we will talk about something very important for any database. Yes, we will discuss transaction and concurrency control for MongoDB. If you may already know that RDBMS is fully ACID compliant, but unfortunately MongoDB is not. Now here ACID means set of properties includes atomicity, consistency, isolation and durability. Now one question may arise that what do you mean by fully ACID compliant? Well, MongoDB can perform atomic operations, but that it does not support traditional locking and complex transaction. In MongoDB, a write operation is atomic on the level of single document, not on the level of multi-document. Now let's take an example of inventory management system and try to understand it. Now let's take one example of inventory database management system to understand transaction and concurrency control in MongoDB. So here is one inventory database and we have two tables, orders and inventory. So let's assume that this inventory database is MongoDB. Let's assume that this inventory database is MongoDB and this both orders and inventory are both in different documents. Okay, so orders is in different document and inventory is in a different document. So in this case, in that scenario you can't remove an item from inventory and add it to order at the same time unless the two things inventory and orders exist in the same document, which they probably do not. Now let's focus on concurrency control. Now there are two approaches. Concurrency control allows multiple applications to run concurrently without causing data inconsistency. Now there are two approaches for the concurrency control. The one approach is to create a unique index on a field that can only have unique values. This prevents insertion or updates from creating duplicate data. Now what this is saying is that we can create a unique index on a field that is already have unique values. Just for example, if we have a customer table, that in that customer table if we have a customer ID which is a unique, so we can create a unique index on customer ID which is already have a unique values. The second approach is to specify the expected current value of a field in the query predicate for the write operations. Now we will discuss another advanced and critical topic, distributed transaction in MongoDB. So first, what is distributed transaction? A distributed transaction is a database transaction in which two or more network hosts are involved. A distributed transaction is a database transaction in which two or more networks hosts. A distributed transaction is a database transaction in which two or more networks are involved. So what does it mean by is that a transaction which takes place in a distributed architecture is called distributed transaction. Guys, we have already talked about distributed database MongoDB, its scalability, and so if there is a distributed architecture and we want to perform a transaction on it, that's called a distributed transaction. We have already discussed that MongoDB does not support a real transaction. Now here real means fully supported transaction. We will take another example to discuss distributed transaction. So here is the example of distributed financial system. As you can see in the figure, this is a distributed architecture. We have n cluster from 1 to n, and we have assumed that each cluster has 100,000 accounts, or we can say 100,000 records in it. Now let's say we want to perform one transaction between multiple accounts, okay, and in this scenario we will assume that both accounts are in different clusters. So we cannot guarantee that both of the transaction would be located in the same partition or the same document, okay, and it's more likely that they would be in a separate nodes. That means that we need to have a distributed transaction that would deduct funds from the first account and add funds to the second account and then commit. So this operation has to be atomic. In this case, entire operation will be success or a failure. And we must ensure that both accounts are updated. So this kind of transaction say are called distributed transaction, and distributed transaction cannot be cannot be done in a MongoDB database because MongoDB database supports transaction, or you can say atomicity, in a single document. So let's say if we have two accounts which are on the same cluster or a same document, then this transaction can be possible. But in the real time scenario, in the real world scenario, it is not likely that we will have two accounts in a same document. So that's why distributed transaction is not supported by MongoDB. One more advanced as well as critical topic is replication. Now, as name suggests, replication is the process of creating and managing duplicate versions of database. Replication provides redundancy, which increases data availability. So what happens is by replication, there are many replicas that are created of the data sets which are already available, and it increases the data availability. Synchronization is important aspect when we are dealing with replicas of database. Replicas synchronizes with each other so that any changes made to a particular replica reflects on all other replicas. Replication enables many users to work with their own local copy of database. So there will be many copies of database using replication, and um, it will very helpful when failover occurs. So let's say if one node is just let's say one node fails. So what happens is that data related to that node goes down. But if we have replication, then it is very likely to be it is very likely to have duplicate duplication replicas of that data set, and we can beat that failover. Now let's go deep into replication. A replica set in MongoDB A replica set in MongoDB is a group of MongoDB processes that maintains the same dataset. Here, MongoDB is the primary daemon process for the MongoDB system. MongoDB handles data requests and manages data accesses and also performs background operations. A replica set contains several data-bearing nodes and one optional arbitrary node. Of the data-bearing nodes, one and only one member is deemed the primary node, while other nodes are deemed secondary nodes. So what it is saying is that structure of replica set is that we will have some data-bearing nodes and we will have one optional arbiter node. We will talk about that arbiter node in the later, but among those bearing nodes, one and only one member will be primary node and others will be secondary. The primary is the only member in the replica set that receive write operations. MongoDB applies write operation on the primary and then records the operation on the primary's op log. Secondary members replicate this log and apply the operations to their dataset. Here, oplog is a special collection that keeps rolling records of all the operations that modify the data in the database. Now, this process is very simple. What happens is actually MongoDB is the primary daemon process of MongoDB system. So MongoDB is the head of MongoDB system. Okay. Now, if any changes made to that database, then first MongoDB will tell all these changes to the primary node via oplog. Now the oplog is a log, you can say, which keeps all the tracks of all the changes that made to database, and once the primary node get the changes, it will tell the rest, which are the secondary nodes, so this way replication will work. Now as you can see in the figure, primary node will receive all the write operation via oplog, which is operational log. Once primary node gets all the changes made to database via oplog, it will record all these changes to its datasets in its operational log. Okay, and this operational log will be available to secondary nodes, and they will also change the datasets according to the changes, and this way replication across all the nodes will work. A replica set can have only one and one A replica set can have one and only one primary node. In some circumstances, two nodes in a replica set may transiently believe that they are the primary, but at most one of them will be able to complete write operation. Now a question may arise that what if primary node become unavailable? Then guess what? Just like democracy, an election determines the new primary node. As you can see in the image on the right, on the first image, one primary node becomes unavailable. So in the second image, as you can see, election takes place and new node on the which is on the left side is selected as primary node, and the right hand side is selected. Now let's say what if what if now let's say what if the newly elected primary node becomes unavailable again. Like we in this case we have only two nodes and one of them becomes unavailable. So in that case an eligible secondary node will hold an election to elect itself the new primary. Now, as we discussed earlier, that there is an optional arbiter node that can be available in the application. Okay, so why we need that arbiter node? Let's take one example and understand it. So let's say we have an architecture where there are 5 nodes and one of them is the primary node. Now suddenly primary node becomes unavailable, and as the process says, an election will take place. An election will take place between 4 nodes. Now let's assume that in the election one node gets 2 votes and another gets also 2 votes. Now it means it's a tie. So now who will decide the primary node? Because in the election no one get the majority of votes. So to avoid this kind of situation, we have an optional arbiter node. This node, as you can see in the figure, it's a vote only node. So it does not maintain any data set. It is just there to just vote. The purpose of an arbiter is to maintain a quorum in a replica set by responding to a heartbeat and election request by other replica set members. Now let's take this example. Here there are 5 nodes and number 5 node is a primary node. Okay, and let's say that this primary node is become unavailable. So this become unavailable. So there are only 4 nodes are left, and as the process says, the election will take place between these 4. Okay, so let's say in the election results we got 2 vote for node 1 and 2 node for node 2. So number 1 and number 2 both node got 2 votes. Okay, now who will decide the primary node? This is a tie and we need a majority in the election to become a primary to get a primary node. Now the last but not the least topic is sharding. Sharding is also an advanced topic of MongoDB. Database systems with large datasets or high throughput applications can challenge the capacity of a single server. For example, high query rates can exhaust the CPU capacity of the server. Now what does it mean is the same that we have discussed earlier about scaling. That if that the data that is generating every minute is a very huge number of data, and not there is one single PC, one single machine cannot process all this data. So we need the concept of scaling to scale the data. There are two methods for addressing the system growth, that is vertical and horizontal scale. Now sharding is a database architecture that partitions the data by key ranges and distributes the data among two or more database instances. Now, as I said, sharding is a technique of scaling. What it does is it just partitions the data and allows scaling. Sharding is a method for distributing data across multiple machines. MongoDB uses sharding to support deployments with very large datasets and high throughput operations. Now we will discuss horizontal and vertical scaling. So let's start with vertical scaling. So vertical scaling involves increasing the capacity of a single server, such as using a more powerful CPU, adding more RAM, or increasing the amount of the storage space. Now friends, we have already discussed this scaling before, but this this is not practical for a real world scenario. If you, let's say if you have one single server which has, let's say, 1 TB of RAM, or let's say it has highest configuration ever, okay, but still there will be some time at when this machine will not be able to process all this data efficiently, because the the um, the amount in which data is generating is very huge. So vertical scaling is not practical for real world scenarios. So the limitation in available technology may restrict a single machine from being sufficient powerful from a given workload. Additionally, cloud-based providers have hard ceiling based on available hardware configuration. As a result, there is a practical maximum for vertical scaling. So, vertical scaling is not a practical solution for real world scenarios. So, let's discuss horizontal scaling. The horizontal scaling involves dividing the system datasets and load. Horizontal scaling involves dividing the system dataset and load over the multiple servers, adding additional servers to increase capacity as required. So this is very basic. So this is the mechanism we have discussed earlier, that we can add more and more servers, and we can divide the workload on those servers. While the overall speed or capacity of a single machine may not be high, each machine handles a subset of the overall workload. So it is not required that every machine it is not required that every machine is highly configured, but whether even if it is not highly configured, we can use that machine, and it is also, and we can divide the workload among those servers. Expanding the capacity of the deployment only requires adding additional servers as needed, which can be a lower overall cost than high-end hardware for a single machine. So guys, this is also a cheap way to scale, and sharding is also a horizontal scaling. And the disadvantage of horizontal scaling is increased complexity in infrastructure and maintenance for deployment. So there will be, let's say, thousands and thousands of servers, So the complexity of infrastructure will be very high, and we need to maintain that servers also. So that is the only disadvantage that have. But other than that, we have advantage of scaling. Horizontal scaling is the way that is horizontal way is the scale horizontal scaling is the horizontal scaling is really helpful in real world scenario too. Now, as we know, in horizontal scaling there will be many servers in the architecture, and each cluster will consist of several components. There will be three components in each cluster. First is shard, second is Mongo, and the third is config servers. Uh, on the excuse me, on the figure, as you can see in the figure, the nodes in green are shard, and each shard contains a subset of sharded data. Each shard can be deployed as a replica set. In the figure, blue nodes are Mongos. The Mongos act as a query router, and they provide an interface between client application and the sharded cluster. And the third one is config server, which is in the orange color. Now the config server store metadata and configuration setting for the cluster. Now let's understand sharding in a bit depth. Okay, MongoDB shards the data at collection level. I hope you guys remember what is collection. Collection is a group of all the documents. So distributing the collection data across the shard in the cluster. MongoDB partitions sharded data into chunks. Now chunks is a little parts of data. Each chunk has an inclusive lower and exclusive upper range based on the shard key. MongoDB partitions the collection using the shard key. The shard key consists of an immutable fields that exist in every document in the target collection. Now immutable is the field which cannot be changed. One has to choose the shard key when sharding a collection. So it means that you have to choose one key which should be immutable, and you have to select it before sharding it. The choice of shard key cannot be changed after sharding. A sharded collection can have only one shard key. So guys, the shard key is kind of password, you can say, that it has to be immutable field, and you have to select it before sharding the process. Okay, the choice of shard key affects the performance, efficiency, and scalability of a sharded cluster. A cluster with best possible hardware and infrastructure can be bottlenecked by choice of shared key. So so as you so it is very important to choose shard key. So it is very important how you choose the shard key. Now let's look at the advantages of the sharding. The first is read and write. MongoDB distributes the read and write workload across the shards in the sharded cluster, allowing each shard to process a subset of cluster operations. Now what it says that MongoDB actually distributes the workload among the servers, among the number of servers. So each server will do its own workload. So in this way we can divide the workload, and we can do the task very faster. The second is storage capacity. Sharding distributes data across the shards in the cluster, allowing each shard to contain a subset of total cluster data. As the data set grows, additional shard increases the storage capacity of the cluster. Now third is high availability. A sharded cluster can continue to perform partial read-write operations even if one or more shards are unavailable. While the subset of the data unavailable, shards cannot be accessed during the downtime. Reads While the subset of data on the unavailable shards cannot be accessed during downtime, reads or write directed at the available shard can still succeed. Now, this means that if one of the cluster is failed, then we can we can use that data sets which are on the fail node by sharding. So guys, the last topic is the disadvantages of MongoDB. Everything in life is come with advantages and disadvantages. So the disadvantages of MongoDB is one of the main disadvantage is that it does not support fully functional transaction. So because of this disadvantage, MongoDB cannot be used in systems like any financial system or any inventory management system. MongoDB does not support join operations also. MongoDB is very memory hungry and server will need a lot of RAM. And MongoDB also have some severe concurrency issues. So guys, these are the references which I used for this video. You can check out You can check out these references if you have any question, or you can ask me directly. Thank you.